Alright, I'm going to start a recording on how to answer this Chapter 7 review. We'll start with graphing exponential equations. And here for this first one, this is a basic function where we don't have any transformation. So we've got y equals 2 times 3 to the x. We know that it's growing because the base is greater than 1. We know the y-intercept is 2. This value always tells us the y-intercept. So I'm going to go ahead and plot the y-intercept there at 2. I know that there's going to be a horizontal asymptote at the x-axis, so it's going to look something like this. We just got to figure out exactly where those points are. To do that, I like to make a table, and I'm going to use the x values -1, 0, and 1. We already know what happens when x is 0, y is 2, because 3 to the 0 is 1 times 2 is 2. Remember, anything to the 0 power is 1. Let's do 1. So this is 2 times 3 to the first power. 3 to the first power is 3 times 2 is 6. And then to the -1 power. 3 to the -1 is 1/3. We have to drop it down to the denominator, so this is 2/3. So I'm going to plot my 3 points. -1, 2/3 is about there. 0, 2 already did, and then 1, 6, 2, 3, 4, 5, 6. I'm going to connect this with my exponential growth curve. Remember, I'm showing that this is a horizontal asymptote. I cannot cross the x-axis. Okay, for this one down here, we do have a shift. We see that we're subtracting 1 from the input and adding 1 to the entire function. That's going to cause me a shift right of 1 and up 1. Okay, so what I'm going to do is I'm going to first graph y equals 2 times 5 to the x, and then I'll shift that right 1 and up 1. So let's just graph y equals 2 times 5 to the x. Same process here. So when x is 0, y is 2. When x is 1, that's going to be 10. And then -1, that's going to be 2/5. So I'm going to go ahead and plot this kind of just lightly. And then I'm going to shift everything. So -1, 2/5 is about there. 0, 2, and 1, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I need to shift these points up 1 and to the right 1. So this one's now going to be to the right 1, so 2/5 and up 1. So right there. Then I'm going to take this one, right 1, up 1. Right 1, up 1. Sorry, I made those a little bolder. Those are the points that I'm going to plot. And if I shift my whole graph up 1, that means the horizontal asymptote has also been shifted up 1. So I'm going to show that horizontal asymptote here. My graph will not go below it. There we go. So I connect those points with my exponential growth curve, and there you have it. If you need more help graphing, you can check out this link. Go back to old homework problems and practice those. Okay, what about functions that decay? Well, we know this one's going to decay because the base is less than 1. Same process. Make my table. When x is 0, y is 2, we should see that this is the y-intercept. What about 1? Well, 1/4 to the first is just 1/4, so I have 2/4, which is 1/2. And then -1, 1/4 to the negative first power is 4. 4 times 2 is 8. So I have -1, 8. 1, 2, 3, 4, 5, 6, 7, 8. I've got 0, 2, and 1, 1/2. Okay, this is a decaying function, so as we go from left to right, it's going to be going down. Still have that horizontal asymptote at the x-axis. Now this one, same process except we have a shift. If we're adding 2 to the input, that means it shifts left 2, and then adding 2 to the output, it shifts up 2. So I'm going to graph y equals 3 times 1/4 to the x, and then I'll shift left 2 and up 2. Okay, so -1 flips this, so 1/4 becomes 4. 4 times 3 is 12. 1/4 to the first is just 1/4, so I have 3/4. going to plot those points, I'm going to shift them. So negative 112 is like up here. I just added some more tick marks there. Okay. 0, 3 and 1 3/4. There we go. But now I need to shift these to the left 2 and up 2. So left 2, up 2. Left 2, up 2. Left 2, up 2. And remember, if we shift the graph up 2, we need to shift the horizontal asymptote up 2. So it's no longer at y equals 0, it's at y equals 2. I'm going to connect these darkly shaded dots with the smooth decaying function. There we go. Alright, let's look at word problems that involve exponential growth. We must memorize this formula for compound interest. You deposit $8,000 into an account that pays 9% interest compounded monthly. Well, monthly means my end value is 12. How much money will be in the account after 4 years? Okay, 9% interest means my rate is 0.09. T equals 4. And then my initial value is 8,000. So the final amount, A, is equal to 8,000 times 1 plus my rate of 0.09 compounded monthly for 4 years. So there's my formula. Let me go ahead and throw that in my calculator. And I get 8,000 times 1 plus 0.09 divided by 12, all raised to the 12 times 4 power. That's $11,451.24. Make sure you write your units, so make sure you write that dollar sign. Example 2, you are hoping to have $12,000 in account by the time your son graduates from high school in 7 years. If the account pays 5.9 annual interest compounded quarterly, that means N is 4. How much money should you deposit today? Okay, this is asking how much do I need now in order to have 12,000 in the future. So in this case, we're not solving for A, we're solving for P. So I want $12,000. I need to solve for P. What do I have to put in now? What's that principal? Now, at a rate of 0.059 compounded quarterly for 7 years. Okay, so I need to solve for P. Well, all this is just a number. I could do order of operations and get a number here. So it's a number times P. To get P by itself, I need to divide both sides by this number. That's going to cancel these out. So P is equal to this. So P is equal to, and we'll put this into our calculator. Go ahead and show you what my screen looks like when I do this. I'm going to do my fraction. Whoops. So in the numerator is 12,000. In the denominator, I've got 1 plus, I'll do my fraction again so it looks exactly like what I wrote down. It's 4 times 7, not 47. There we go. How much do I need now? I need $7,963.93. $7,963.93 is what I need now in order to have $12,000 in 7 years. Okay? Continuous compounded interest, you need to know this formula. PERT. ERT. Your grandparents set aside $10,000 on the day you were born to help you pay for college expenses after you graduate. If they put the money into an account that pays 12% annual interest compounded continuously, if something's compounded continuously, we need to use this formula. How much will we have for college on your 18th birthday? Okay, well, so the final amount is equal to what they put in, 10,000 times E. The rate is 12%, but what's our time? Let's see. Oh, on the day you were born, 18th birthday, so that's 18 years. So that's 0.12 for 12% times 18 years. So I put this into my calculator. 10,000 times e to the 0.12 times 18. I will have $86,711.38. When you go to college, you decide to take out a $20,000 loan to help pay for tuition expenses for your first year. If the lender charges 6% annual interest continuously, how much will you owe by the time you graduate after 4 years? So how much will I owe at the end is equal to what I take out times e to the 0.06 times 4. Put this into my calculator. I will owe $25,424.98. Okay, things can also depreciate. Remember, with depreciation, we have to subtract the rate. The Jones bought a yacht for $80,000 in 2004. That is now worth only $51,000. What is the rate of annual depreciation of the boat? Assuming depreciation will continue at this rate, how much will it be worth in 2016? So this is asking two questions. First, we have to find the rate. Well, we know now it's worth $51,000. It was $80,000. And how long did it take? Well, they bought it in 2004. It is now worth only $51,000. Well, now it's 2017, so the difference between 2004 and 2017, that's 13 years. And this question must have been written a while ago because it says, assuming depreciation will continue at this rate, how much will it be worth in 2016? This was probably written back in 2013 or something like that. Anyways, let's go ahead and find the rate, and then we can worry about the second part. Okay, to find the rate, I'm going to try and isolate r. Well, the first step would be to divide both sides by 80,000. So I'm going to divide both sides by 80,000. That's going to, I'll just write this as a fraction. It's going to be 51 over 80. I just canceled out some of those zeros. So I've got 1 minus r to the 13th. All right, how do I undo this 13th power? Well, I can take the 13th root, or I can raise each side to 1/13th power. So this is 51 over 80 to the 1/13th power equals 1 minus r. And then if I go ahead and just rearrange, get r by itself, I see that I'll go ahead and bring the r over here, and then I'll have 1 minus this, 51 over 80 to the 1/13th power. So if I put this into my calculator, 1 minus 51 divided by 80 to the 1/13th power, I get a rate of depreciation of 0.034. Well, that's 3.4% is my depreciation rate, meaning the boat is losing its value at 3.4% every year. How much will it be worth in 2016? Well, let's go ahead and just find that value. Let's do 2016. So the final amount is equal to whatever it started at times 1 minus our rate, so 0.034 to the, well, how many years from when it was new to 2016? That would be 12 years. So in 2016, we would assume the boat to be worth, put this into our calculator, 80,000 times 1 minus 0.034 to the 12th power is $52,822.08. All right. Okay, so here we go, simplifying. These are pretty quick. 16 divided by 2 is 8. E to the 3x divided by e to the 5x. Remember, If we divide two numbers with the same base, we subtract their exponents. So 3x minus 5x is negative 2x. And then we don't like negative exponents. We're not simplified until those negative exponents are taken care of. I have to drop the base down below. E goes down to the denominator. That makes the exponent positive. Let's do this one here. 10e to the negative 4x to the third. I give the third to each factor, so that's 10 to the third, and then e to the negative 12x. Remember, an exponent raised to another exponent, you multiply. So this is equal to 10 to the third power is 1,000 over e to the 12x. I had to drop e to the 12x down below to get rid of the negative exponent. Let's do this one. 4e to the 5x times 3 to the negative x times 5 to the x, e to the x. Well, I can multiply the numerical factors. 4 times 3 times 5. Well, 4 times 3 is 12. 12 times 5 is 60. And then I have e to the, now I'm multiplying these e's, so I add their exponents. 5x plus negative x is 4x, plus x is 5x. Then over here, same process. 5 times this 1 here gives me 5. And then this is e to the, I need to add the exponents because they're being multiplied together. X plus 2 is 2x plus 2. There we go. Okay, logarithms. Evaluate without a calculator. We just have to remember what a logarithm is asking. This is saying 6 to what power is 216? Well, 6 to the third power is 216. 16 to what power is 1/4? Well, to get from 16 to 4, you have to take the square root, so that's the 1/2 power. And then I need to drop it down to the denominator, so that's going to be negative 1/2. You can verify this with your calculator, but 16 to the negative 1/2 would be 1/4. 6 to what power is 1? 0. Anything to the 0 power is 1. Okay, the next one say evaluate with a calculator. So I just put this into my calculator. I get 1.79. This one, I get negative 0.127. Simplify the expression. Okay, log base 5 to the 5x, we know that if the base of the log and the base of the exponent are the same, they cancel. Same thing here, but hey, 81 is not 3. I need to make 81 3. So this is log base 3 to the 3 to what power is 81? 3 to the 4th, I believe, is 81. Yep, 3 to the 4th is 81. Now, 3 to the 4th to the x is 3 to the 4x, and now we see that these cancel, and I'm left with 4x. Let's do the same thing here. 2 to the 5th is 32. So this is 5x. Of course, you can always pause and go back. Rearrange into exponential form. 8 to the y equals x. This we just have to remember that the base stays the base, then it's 8 to the y power equals x. Here, natural log, we have to remember the natural log's base is e, so e to the y equals x plus 1. Rearrange into logarithmic form. Okay, so it's log base 2 of y equals x. Log base 3 of x equals 4. Now remember, we don't have an example on here, but what if your base was 10? Remember, if your base is 10, you just write log. You don't write log base 10. What if your base was e? Right? If this 3 were an e, you would write natural log. All right, expand the expression. Remember, to expand means to write it into as many terms as you can. Well, there's going to be 1, 2, 3 terms because there's 3 factors. It's going to equal log base 4 of x. Then any factor in the denominator is going to be negative. So negative log base 4 of 3 and negative log base 4 of y. Okay, we've got the natural log of 4x squared y. Typically this would be in parentheses to make it clear that we're taking the log of those three factors. So this is going to be natural log of 4 plus 2 natural log of x plus natural log of y. If you can see where we got that. Okay, here, expand. Once again, let's assume that, that those should be in parentheses. So this is log base 6 of 36 plus 2 log base 6 of x. Now, if you can take the log, go ahead and do it. So log base 6 of 36 is 2 because 6 to the second power is 36. So this would be the fully simplified, or I should say expanded form. Condensed, that's the opposite of what we just did. When we have two logs with the same base, right, they both have a base of 10 that are being added, we're going to multiply. So this is going to be x squared times 11. And so typically we're going to write that as log 11x squared. Remember, I got this squared from this 2 in front. You bring the 2 up to the exponent. Okay, this one. They both have a base of 5, so that means I can write this, I can condense this. They're being multiplied, so I have log base 5 of 4 times x to the 1/3. Oh, sorry, log base 5. There we go. Then this one. They're being subtracted, so this is a natural log of a quotient. Well, we've got 2 to the 6th and y to the 4th. We'll go ahead and actually do 2 to the 6th. 2 to the 6th is 64. There we go. So this would be fully condensed. Okay, now we get into solving exponential equations. We can solve exponential equations two ways. We can either create like bases, or we can take the log of both sides. Well, I notice that 8 and 32 can both be written as bases of 2. So this is 2 to the 3rd, and 32 is 2 to the 5th. An exponent raised to another exponent says you multiply, so that's 3x minus 3. And this would be 15x minus 10. Once you have two numbers that are equal to each other with the same base, that means their exponents must be the same. So I can solve this. This is going to be 12x equals negative 3 plus 10 is 7. So this is 7/12 equals x. Just verify. I like to check my work. 5, 15 minus 10, yep. So it's 12 and then 10. Yep, cool. Okay, over here, 25 and 125 can both be written as bases of 5. So I'm going to change this to 5 squared. And I'm going to change this to 5 to the 3rd. But I need to bring this from the denominator to the numerator. And the way I do that is I write this as 5 to the negative 3rd power. I have to negate this exponent to bring it to the numerator. Okay, here I'm going to go ahead and 2 times 10x is 20x. 2 times 8 is 16. Bring that down. And then I've got 5 to the negative 12 plus 6x. Now I can set the exponents equal to each other. I'll do that here. So this is 20x plus 16 equals negative 12 plus 6x. Alright, so this is, let's go ahead and subtract 6x from both sides, so that's 14x. Then I'll subtract 16 from both sides, that's 28. Divide both sides by 14, I get negative 2. Okay, 11 to the 5x power equals 33. 11 and 33 cannot be written as the same base, so I need to take the log of both sides. Remember, logarithms undo exponents. They do that by using the power identity. That means I can bring this 5x out to the front. Now I have a linear equation. Remember, 5 is just a number, log 11 is just a number. So to get x by itself, it's It's currently being multiplied by 5 in log 11, so I need to divide by 5 in log 11. So log 11 cancels, 5 cancels, I'm left with x. I put this into my calculator, x equals, so log 33 over 5 log 11. So that's 0.29. Okay, over here, I need to get solving for x, so I first need to isolate this e to the 2x. So I need to subtract 7 over 2. Okay, you could do this in your calculator, but I'll just go ahead and do this. 1 second. What's up?
Hi,
Hey.
do you know if Mr. Ostransky's here?
He's not here yet.
Okay.
No, I check in a little bit.
Okay.
Yeah. Alright, back to it. Okay, so 4 minus 7 halves. Well, 4 is 8 halves. So this is 1 half. 8 minus 7 is 1. And then I need to multiply both sides by 4 thirds. 1 half times 4 thirds is, so that'd be 4 over 6 is 2 thirds. Makes sense? Yeah, 2 thirds. There we go. Alright, now to undo this exponent here, I could take the log of both sides, but even easier, if I notice that my base is e, I'm going to take the natural log of both sides. These will cancel. Remember, if the base of your exponent and the base of your log are the same, they cancel. So this is 2x equals the natural log of 2 thirds, divide both sides by 2, natural log of 2 thirds all over 2. So x equals the natural log of 2 thirds divided by 2 is negative 0.20. Okay, now I have some logarithmic equations. Remember, to undo logs, we can exponentiate. So I'm going to exponentiate both sides with the base of e. That's going to cancel out the logs. So I have x plus 19 equals 7x minus 8. Linear equation. So I get 27 equals 6x, divide both sides by 6. So I got 27 sixths. We need to check for extraneous solutions when we solve logarithmic equations. Remember, we can't take the log of a negative. 27 sixths plus 19, that's positive. 7 times 27 sixths minus 8, that's also positive. If you need to use your calculator to check that, go ahead. Okay, over here, we both have a base of 8, so I'm going to exponentiate with the base of 8. Those are going to cancel. I have 5 minus 12x equals 6x minus 1. Once again, linear equation, I'll add 12x to both sides. That's 18x, I'll add 1. So there we go. Divide both sides by 18. 6 over 18 is 1/3. Let's check to make sure we're good. 5 minus 12 times 1/3. Well, 12 times 1/3 is 4. 5 minus 4 is 1. So we're okay there, that's positive. 6 times 1/3 is 2, minus 1 is 1. So we're good. Both of those are positive. Okay, last 2 questions, and it's review of previous chapters. I'll stop this video after these 2 questions. Okay, solve this equation. Well, I can't solve a logarithmic equation until I just have one log, so I need to condense this left-hand side. I notice that I can condense because the bases are the same. They're separated by addition, so I'm going to multiply. This is going to be x times x minus 2 equals 3. So log base 2 of x squared minus 2x equals 3. I need to undo this log by exponentiating both sides with the base of 2. So this is x squared minus 2x equals 8. 2 to the third is 8. This is a quadratic. I need to put it in standard form. And then I'm going to try and factor. Do I have 2 numbers that multiply to get negative 8 but add to get negative 2? That would be negative 4 and positive 2. So this is x minus 4 times x plus 2. That means my 2 solutions are x equals 4 and x equals negative 2. Now I need to check to see whether either of these is extraneous. Remember, we cannot take a log of a negative number. If I plug in 4 here, log base 2 of 4, fine. 4 minus 2, yeah, that's fine. Let's try negative 2. Nope, I can't take the log of negative numbers, so that's extraneous. So my only answer is 4. Same thing here. I need to condense. And I was able to condense via multiplication because these two logs that have the same base are being added together. So I multiply the two arguments, 3x and x minus 1. Okay, I exponentiate both sides. So 3x, sorry, this is 3x squared minus 3x. If I distributed 3x squared minus 3x equals 6 to the third, I think we said was 216, but let's double check. Yeah, 216. All right. I noticed that I can divide out of 3 to make my life easier. So it's x squared minus x equals 216 divided by 3 is 72. Put this in standard form, meaning all the terms are on one side equal to 0. Let's see if we can factor. Two numbers that multiply to get negative 72 but add to get negative 1. That's negative 9 and 8. And then I can factor. So my two solutions are x equals 9 and x equals negative 8. We have to check for extraneous solutions. 9, that's positive, negative 8, nope. That makes a negative argument. 3 times negative 8 is a negative number. Can't do that. So my answer is x equals 9. Okay, we've got some review. I'm not going to do that video now. I may do that later and let you know if I post that. Good luck in the review, good luck on the test tomorrow.